Suppose this is your length, okay, and this is your breadth, and you form this kind of a cylinder here by revolving this rectangular sheet. Okay, so this time my height will be the length, and the breadth will be, the radius will be this time half of the, in fact not this way, this dotted line will not go this way. We are revolving this about the this this axis. Okay, this time the radius will be half of the breadth. So clearly, a cylinder is a surface that is generated by a rectangular sheet which is revolved about the middle point of the length or the breadth. Okay, at its axis, about the line joining the middle point of the length or the breadth at its axis. So that is what the actual definition of cylinder is. And in class 8, you already have done that the volume of a cylinder is pi r square h. The volume, the surface area, the curved surface area are all defined by the radius and the height of the cylinder. Okay. If you know the radius and if you know the height, you can calculate everything. So volume is pi r square h. Curved surface area, or curved surface area is also called the lateral surface area. Whether you call it curved surface area or whether you call it lateral surface area, it means the same thing. Now, what do you mean by the lateral surface area? Lateral surface area means apart from the two circles that are on top and below, only this part of the cylinder. Okay, the one that is rounded part of the cylinder, that is the curved surface area of the cylinder. Okay, so that is the lateral surface area or the curved surface area. It is 2 pi r h, and the total surface area is the curved surface area plus area of these two circles, which I am shading in blue. That is 2 pi r h plus pi r square plus pi r square. And if you take 2 pi r common, this is the formula that you're going to get. So we can use the formula directly. Okay. Next, we come to the case of a hollow cylinder. Now, what do you mean by a hollow cylinder? All these results were for a solid cylinder. Next, we come to the case of hollow cylinder. Hollow cylinder, also in class 8, I had worked out a problem on hollow cylinder, wherein you have a cylinder with the outer radius capital R, and you have an inner radius small r, and this is the material here. This red part that I am shading, okay, this is your material out of which the hollow cylinder is made, and this part is the hollow. This part that I'm shading in green, this is your hollow. Okay, so clearly it has an outer part and an inner part. Two cylinders are there, outer cylinder and an inner cylinder. The volume of this will be, if you remember all the results of the solid cylinder, you'll be able to do it for hollow cylinder also. Okay, you don't need to remember any results for hollow cylinder. The volume of this hollow cylinder will be volume of the outer cylinder minus the volume of the inner cylinder. Okay, that is the volume of the material out of which it is made up of. I'll solve one problem on this. Not only that, but also if you see the top part here, that this part has been left out. And this I'm not talking about the area here first. Okay, so the volume will be outer minus inner. Outer radius, you know, capital R, inner radius you know, small r. So you can find out the outer volume and minus the inner volume. You will get the volume of the material. Next, what we come to is what should be the surface area of this. This is the main thing, the surface area. And when we are talking about surface area uh, of a hollow cylinder, we talk about the surface area that is outside, we talk about the surface area that is inside, and also we talk about this area, this semicircular ring. Is not semicircular, in fact circular ring that you see here at the top and below, right? I've drawn here this. So outer surface area minus inner plus inner surface area plus the surface area of this circular ring into 2, because you have two circular rings, one at the top and another below. Okay, so this is the total surface area. So we'll be working out problems based on this. Okay, but if you understand this concept of in outer surface area and inner surface area and the area of this concentric circles into 2, then that is what the total surface area is. Now, remark I have given you here. Okay, in remarks, in fact, I have given you a definition of cylinder in this remark. Okay, in the second remark, actually, this one. In the second remark, I was talking about this part. Okay, I'm talking about this part, the definition of the cylinder. Let us come to the first remark. When a rectangular sheet is rolled into a cylinder, rectangular sheet of paper, I gave you a demo of all this in class 8. When this is rolled in the form of a cylinder, then what happens? This part, if this the length of this is L, this part becomes the circumference of this circle, this one. This part becomes your L. Okay, and what can you see about the radius of this of the cylinder? When you are rolling it along this, you are making these two
L by
sides
2.
meet. Yes. What can you say about the height of the cylinder? In fact, height. If I say that the breadth is B, what can you say about the height of the cylinder? You can say that
So
the
height
height,
also will be B.
yes, height will be B. This height will be B. And this L actually becomes the circumference of the base. So from the circumference of the base, you can find out the radius of the base also, right? If you know the circumference of a circle, you know how to find out the radius of a circle. So from these two, you can find out the radius of the cylinder and the height of the cylinder. Okay, when this is rolled, when this is rolled along the breadth, what if it is rolled along your length? Then what happens? Same thing, but things change a little. What if this is rolled? This has been rolled along the breadth, right? Along the breadth. Now I'm rolling this along the length. Then what happens?
So then length becomes the height.
Yes, length becomes your height. What about the breadth? What about the breadth?
So it becomes a circumference.
Yes, circumference of this part. This becomes length, this becomes B. Once you know the circumference of this circle here, you can find out the
You
radius of
can
this
take out
circle.
the radius.
Once you get the radius, you know the radius of the cylinder and you know the height of the cylinder also. Now you can find out whatever you want. If you want, you can find out the volume. If you want, you can find out the surface area, or the curved surface area, or the total surface area, whatever. Okay, so that is what this is. Okay. Um, Let us move on to the problems on this cylinder. I've already discussed back in class 8, so I will not do the basic problems here. Okay. Besides, um, the time also seems to be a little constrained. So cylinders, I won't go much into the detail. Let us see this one. Yes, the barrel of a fountain pen, cylindrical in shape, is 7 centimeter long and 5 millimeter in diameter. So this is your fountain pen, the barrel, in fact, of the fountain pen. Have you, any one of you, do you use fountain pen? Have you heard about
Yes,
fountain
sir.
pens?
Yes, sir, I use once.
Hmm. Thank God, fountain pen, 7 centimeter long. The barrel is 7 centimeter long, and 5 millimeter in diameter. Okay, this 5 millimeter in diameter. A full barrel of ink in the pen will be used when writing 310 words on an average. So if you have ink in this barrel, and if you write 310 words, then you can use up the entire barrel. That is what it means. How many words would use up a bottle of ink containing 1/5 of a liter? Now, if you have an ink bottle, okay, and that means how many characters will you be able to write? Okay, how many uh, words will you be able to write? Not characters, in fact, words. How many words will you be able to write if you use only 1/5 of a liter? And what is 1/5 of a liter? How much is 1/5 of a liter? Can you tell me in milliliter? 250 ml, right? Actually means how much words can you write in 250 ml? Okay, but we are not concerned with ml here. We, okay, we only work with liters. 1/5 of a liter, fine. So the question here is, if 1/5 of a liter is given to you, how many words can you write with that 1/5 of a liter of ink? So first of all, let us find out the volume of this cylindrical barrel. Okay, the radius is given to be 5 millimeter. Let us convert this to centimeter, which comes to 0.5. Okay. Um, oh, this diameter is given. Sorry. So the radius will be 5 by 2 millimeter. Okay, which comes to 2.5 millimeter. Now, if you convert, because height is given in centimeters, let us convert this to centimeters. 2.5 divided by 10, which comes to 0.25 centimeter. So that is what your radius is, and the height is given to be 7 centimeters. So therefore, what should be the volume? Volume of ink in the barrel, pi r square h. Height is 7. These two cancel off. So simply get 22 into 0.25 into 0.25. Let us keep it as it is. We- If you multiply, then it's no point multiplying actually, because it's better if it will leave it this way, because this is not our answer. So we have got this in centimeter cube. Okay, so this much centimeter cube of ink was there in the barrel. Okay, now 1 liter, that this is what we are talking about here, that 1 liter is the same as 1000 centimeter cube. Okay, And we have got this in how much ink are we given here? We are given 1/5 of a liter. Therefore, 1/5 of a liter means 1/5 of 1000, that means 200 centimeter cube. So how much of ink are we given to write? We are given 200 centimeter cubes of ink to write. And the question is, how many words can you write with this 200 centimeter cube of ink? So first of all, in this much centimeter cube of ink, how many characters are we writing? How many words are we writing? 310.
310.
So 20 with with 22 into 0.25 into 0.25 centimeter cube of ink, 310 words can be written, right? With 1 centimeter cube of ink, how many words can we write? 310 divided by 22 into 0.25 into 0.25 words can be written. Therefore, with 200 centimeter cube of ink, 310 divided by 22 into 0.25 into 0.25 into 200. This much words can be written. And what is the value of this? If you calculate, the value of this will come to 45090.9, which you round it off to 45,091 words can be written. Okay. So if 1/5 of a liter of ink is given to you, that is 200 centimeter cube, in I've converted liter to centimeter cube, then you can write 45,091, and that was what your question was. Okay. Let us see number. Yes, let us see number 5 here. The ratio between the curved surface area and the total surface area of a cylinder is 1:2. Find the volume of the cylinder given that its total surface area is 616 centimeters square. Okay. So curved surface area given here, number 5, given here is curved surface area. Ratio of the curved surface area to total surface area is 1:2. That means I can take the curved surface area as K, and I can take the total surface area as 2K. Okay. Given that its total surface area is 616. So therefore, what is the total surface area given? 2K is equal to 616. From here, we can find out the value of K. 308. Okay. This is the value of K. So what is the total surface area here? In fact, the curved surface area now. Therefore, curved surface area is K,
308 centimeters square.
308 centimeters square. We know the curved surface area as well as the total surface area. Now the question here is find the volume of the cylinder. For volume, what do we require? For volume, we require the radius, and we
And the
also
height.
require the height. Okay. So since we know the curved surface area, if the radius of the cylinder is r and the height is h, therefore 2 pi rh is the curved surface area, and this is how much we have found out this to be, 308. So from here, if you put the value of pi, in fact, There are two unknowns here, R and H. So we can calculate RH. What is RH? RH is 308 divided by 2 pi. Now you can put the value of pi. If any value of pi is given here, then you can put that value. Since nothing is given, we shall use 22 by 7. Okay. So this now comes to 49 because this will cancel. Okay, this all will cancel. So this comes to 49. RH. The product of R and H comes to 49. We have used total the value of the curved surface area here to get RH is equal to 49. Now we shall use this is we also know the total surface area. We know the total surface area to be 616. We shall also use that. What is the total surface area? 2 pi r into r plus h, right? Is equal to how much is the total surface area given? 616. So now what you do is you separate this, multiply this 2 pi r square plus 2 pi rh is equal to 616. 2 pi r square. And what is the value of RH that we have calculated? It is 49. So this RH becomes 49. So now we can calculate the value of R from here. 2 pi r square plus 98 pi is equal to 616. You can put the value of pi here, or you can put it later also. You can take pi common here. 2r square plus 98 is equal to 616. Now you can put the value of pi. 22 by 7 into 2r square plus 98 is equal to 616. That means 2r square plus 98, 616 into 7 divided by 22. Let's cancel this. How much do we get? This will cancel 5, 6 with 11. This will cancel 28. And 2r square plus 98. How much is 28 into 7? 196. So that means 2r square is 196 minus 98. That means 2r square is 98. That means r square is 98 by 2, which is 49. That means r is square root of 49. It's 7. You've got the radius as 7 centimeter. How do you find out the height? We know that RH is equal to how much? 49. That means H is equal to 49 by R. Put the value of R here. You get 7. So height and radius both are equal to 7. Now can you find out the volume? Pi R square H. Pi 7 square into 7. 22 by 7 into 7 into 7 into 7. 22 into 49. Okay, so this comes out to be 1078 centimeter cube. Okay, so in this problem, what we saw was that two things were given: the curved surface area and the two things were given. The first was the ratio of the curved surface area to the total surface area and the total surface area. With the help of the total surface area, I found out the curved surface area, and we used the formula of curved surface area to find out this relation between radius and height. What is the relation? We got RH is equal to 49. This was the relation that we got. Now we use the fact that total surface area, the formula for total surface area, we used to find out the radius here as 7 centimeter. and we use this relation also. Okay, once we found out the radius, we again use this relation to find out the height. So that is what the in short the problem is. Now this problem number this one I can't see the number, but this should be number 6, I think. Yes, number 6 problem is exactly as the cylinder is being rolled, so you can do it on your own. Okay, when a rectangular piece is rolled, I showed you that the length, if it is rolled along the length, then your breadth becomes the circumference of the base and height becomes the length. That in the beginning I showed you. What I am going to work out here is a problem on hollow cylinders. This one, a lead pencil. But since I don't have time left here, I'll stop here for today.